In this video, we will discuss section 4.2 isosceles and equilateral triangles. We will cover both notes and practice problems with these triangles. First, let's review the key parts of an isosceles triangle. The definition of an isosceles triangle is that it's a triangle with at least two sides congruent. And they are very common in the real world. You see them in bridges, buildings, etc. The congruent sides of an isosceles triangle are what are called the legs. So in this case, this is a leg of the triangle, and this is a leg of the triangle. The third side is what is called the base of the triangle. Then we have the different types of angles. The two congruent sides form what is called the vertex angle, and that's the angle at the top of the triangle between those two legs. So this would be my vertex angle. And then the last thing is that the other two angles are what we call the base angles. And they're on both sides of the base of the triangle. Now let's review the theorems of isosceles triangles. The first theorem says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So for example, these two legs are congruent, which would mean angle A and angle B are congruent. Or these are the base angles. And similarly, it says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So since these base angles are congruent, we can conclude that the sides are congruent. So essentially what this means is that congruent legs means that you have congruent base angles, and they're interchangeable ideas that we can use to solve problems. So in our first example, since the base angles are congruent, we know that this is an isosceles triangle so that the sides are congruent. So I could say that 2x plus 4 equals 3x minus 10. So if I solve, I'm going to bring all my x's to the right. So I'll have 4 equals x minus 10. And then I'm going to move the 10 over to get 14 is equal to x as my final answer. For the next example, we have the figure turned, but we still see those two base angles are congruent. So this again means that it's an isosceles triangle. So these two sides, which are our legs, are congruent. So now I could say 2x plus 6 equals 3x minus 6. So I would solve by bringing all the x's to one side. So I could subtract 2x from both sides. So I'd have x equals x minus 6, and then I'd have to move the 6 over. So you would get 12 is equal to x as your final answer. Now for the next example, we already know that this is an isosceles triangle. Since those sides are congruent, and since the sides are congruent, that means the base angles at the bottom of those sides are also congruent. So this angle is congruent to this angle. Now, while we don't know anything to set them equal, since this is 3x, I can label that this is also 3x, because we know base angles are always the same. Now, to write an equation, what we know is that the angles in a triangle always equal 180. So I could say in this case, 3x plus 90 should equal 180. So if I solve, I'll have 6x plus 90 is 180. Subtract 90. So you get 6x equals 90. And divide by 6 to get that x is equal to 15 as your final answer. Now for this example, again we have the two sides are congruent, which allows us to say that this is an isosceles triangle. Now because of the fact that it's an isosceles triangle, we know that these base angles are congruent. So since this angle is 6x plus 6, this allows me to say that this angle right here should be 6x plus 6 as well. So if I want to solve, we can use that idea that the angles in a triangle equal 180. So my angles would include the 2x plus the 6x plus 6 plus 6x plus 6 equals 180. So if I simplify, I can combine like terms. So 14x plus 12 equals 180. Move the 12 over by subtracting it from both sides. So you get 14x equals 168. And then divide both sides by 14 to get that x is equal to 12 as your final answer. For this next example, I have to find the value of x and y. Now, we can't necessarily find anything with x and y quite yet, but what I could do is I know that these angles form a line, so they add to equal 180. So if I call this angle A, I know that 110 plus A should equal 180, and when I solve, I'll get A is equal to 70. So this means that this angle right here has a measure of 70. Now, the next thing we know is that since these markings are here, we know that this is an isosceles triangle. So this allows us to say that the base angles are congruent. So since this angle here is 70, I can assume that this angle over here, or my other base angle, would also be 70. So I would know that y is equal to 70. The last thing is I need to find the measure of this angle x. And we know that all the angles in a triangle equal 180. So if I consider my big triangle, I'm adding them all up to equal 180. So one of my angles is x, 70, and 70. So I could say that x plus 70 equals 180. So you would get x plus 140 equals 180. Subtract 140 from both sides. So you would get that x is equal to 40. So your final answers are x equals 40 and y is equal to 70. In the next example, we have to solve for x, y, and z. So first, if I look at this angle right here, I have that this 125 and the x form a line, so they should add to equal 180. So you could say 125 plus x should equal 180, and when you subtract that from both sides, you get that 180 minus 125 gives you a value of 55. So I can say that x is 55, and that's what this angle measure is. Now, because this is an isosceles triangle here, we know that the base angles are congruent, meaning that this angle here and this angle here is congruent. So if this angle is 55, then I know that this angle over here is also 55. Now, if I look at the triangle, I have this triangle here. We know that all the angles in this triangle equal 180. So if I look at my angles of the triangle, we have a y of 55 and a 55. So my equation would be y plus 55 plus 55 equals 180. So you get y plus 110 equals 180. So y is equal to 70. The last thing we need to find is this angle z. Now what we should see is that this angle z and the 55 form a line, so they equal 180. So you could say that 55 plus z equals 180. So when you solve, you'll get that z is equal to 125. In our next example, we have two isosceles triangles back to back. And what we know is that when we have an isosceles triangle, we know that the base angles are congruent. So for this triangle on the left, we know that the base angles are these angles. So since this angle is 50, this angle is also 50. So I could write my equation to be x plus 50 equals 180. So you'll have x plus 100 equals 180. And when you solve, you get x is equal to 80. For the other triangle, we know that these are base angles that are congruent. And while I don't know what the base angle is, I know that this angle is y, so I can call this base angle also y. So this would mean that the angles of the triangle are y plus 100 plus y equals 180, since all the angles in a triangle add to 180. So you have 2y plus 100 equals 180. I can subtract the 100 from both sides. So I get 2y equals 80. And then finish solving by dividing both sides by 2 to get y is equal to 40. In this next example, I have to solve for m and n. Now the challenge of this problem is deciding which triangle to start with. You could choose whatever we need to. However, we're going to have to start with this 126 because it's the only actual number I have in this problem, and use this 90-degree right angle. But to start with the 126, if I look at the triangle on the right, what we see is that we have an isosceles triangle. And we know that whenever we have an isosceles triangle, that the base angles are congruent. So since this angle right here is n, that means this angle over here is also n. So if I use the fact that the angles in a triangle equal 180, I could say that 126 plus n should equal 180, being my angles in my triangle. And then I can simplify this to solve. So I'll have 126 plus 2n equals 180. Subtract the 126 from both sides. So you get 2n equals 54. And then we finish solving, you get that n equals 27. For the other triangle, we can't assume anything about this value of m quite yet because I don't know what this angle is. However, what I do see is that this angle of 126 and this angle form a line, so we know that they equal 180. So if I call this angle A, I could say A plus 126 should equal 180. And when I solve, I'll get that A is equal to 54. So if I label this as instead of being A, I now add that this is 54. What I can use is I can say that I look at this triangle over here now, and I have the 54-degree angle, the right angle, and this angle M, and they should all add to 180. So 90 plus 54 plus M equals 180. So I have 144 plus m equals 180, and when you solve, you get that m is equal to 36. In this next example, we have to kind of work backwards and work in two separate triangles to get our final answer. First, let's start by focusing on the smaller of the two triangles. So I have this smaller triangle here, and we know that this is an isosceles triangle, which means that the base angles are congruent. So since this angle is n, this means that this angle over here is also n. So I could say n plus 90 equals 180. So when I simplify that, I'll get 2n plus 90 equals 180. So I'll subtract 90 to get 2n equals 90 and divide by 2, so you get n equals 45. Now the next thing, before I focus on just that m, I'm going to look at the whole big triangle. So I'm going to say this is my big triangle here. I have this 50-degree angle as one of my angles. I'm going to call this big angle x, and this other big angle x as well. So my other two angles here are x. So if I use this big triangle, I could say I have 50 plus x equals 180. So 50 plus 2x equals 180. So you subtract the 50 from both sides to get 2x equals 130, and then divide by 2 to get x is equal to 65. Now if we know that x is 65, and we now know from the previous problem that this angle n is 45, what we have here is a little plus little equals big problem like we learned in chapter 1. Because if I look at this, we know that the big angle here is 65, and then the two little angles that I have, one of them is this 45, and the other one is this m, which I don't know. So if I use the little plus little equals big idea, I'd have m plus 45 equals 65, and I would subtract 45 from both sides just to get that m is equal to 20. So it involves using the little and the big triangles and then subtracting your two answers. The next theorem states that the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So because of the fact that this segment splits these top angles in half, we can automatically assume that this is a right angle and this is a right angle as well. So the way this is applied in problems is if we see in this problem we have something like this where these both have this congruent marking. So since this angle is 42 and the mark means that this is 42, we can automatically assume that these are right angles. So that gives us that x is equal to 90. Now, if I use the triangle to solve for y, and we know that this is 90, I have 42 plus 90 plus y equals 180. So you get 132 plus y equals 180. And when you solve, you'll get that y is equal to 48. In the next example, we're following a similar process. We're not given quite as much information. What we know is that these are marked as being congruent. So since these are congruent, since this is labeled as y, I know that this is also y. Also, that theorem allows us to say that since those are congruent, we can assume that these are right angles. So that this angle is 90 and this angle is 90. Additionally, because this is an isosceles triangle, we can assume that these base angles are congruent. So since this angle is 63, this angle is also 63. Now to solve, we can approach this one of two ways. One way would be to use one of these little triangles. So when I set this up, I would have y plus 90 plus 63 equals 180. The other way would be to use the big triangle. So if I want to use this big triangle, I would have all of these angles. So at the top, I would have the two y's, because it forms the whole angle. So you'd have y plus the two base angles. So it'd be plus 63 plus 63 should equal 180. But regardless of which method you choose to use to solve, you're still going to get an answer of y is equal to 27. Next, let's review equilateral triangles. An equilateral triangle is a triangle that has three congruent sides. Now, what the theorem says is that a triangle is equilateral if and only if it's equiangular. And equiangular means all the angles are equal. So if I called all these angles x, we would have x plus x plus x equals 180. So you would get 3x is 180, which gives us that x is equal to 60. And this allows us to come to this more important of our conclusion. Each angle of an equilateral triangle measures to be 60 degrees. And this is always true for every equilateral triangle. So essentially, what we know is that if all the sides in a triangle are congruent, all the angles equal 60 degrees. So for example, in this triangle, because all the sides are congruent, we know this is an equilateral triangle, which means that all angles are 60 degrees. So this angle is 60, this is 60, and we know that this angle here should be 60 degrees. So I could say that 6x should equal 60, so I divide both sides by 6 to get x is equal to 10. For the next example, we know that all the angles are equal, and since all the angles are equal, we can assume that it's going to become equilateral. Because they'd all be 60, which means that all the sides are the same. So they're all congruent. Now this allows us to say that 6x minus 5 is equal to 5x, being our two side lengths, and then I would solve. So I can subtract the 6x from both sides to get negative 5 equals negative x, and divide both sides by a negative 1 to get 5 is equal to x. In the next example, we know that this is an isosceles triangle, and since it's isosceles, we know that these base angles are the same. So if I call my base angles the same, I would have 60 plus a is 180. So you would have 2a plus 60 is 180, which gives us that 2a is 120. So a is equal to 60. Now, if all these angles are 60, this means that this is an equilateral triangle, because all these angles are 60 degrees. So this side, I can now say that all of these sides are congruent. So this will allow me to say that this 3x plus 8 should be the same as this 4x minus 4. So I'll have 3x plus 8 equals 4x minus 4. So if I bring my x's to the right, so I'll have 8 equals x minus 4, and then move the 4 over, I'll have 12 is equal to x as my final answer. Now for this first triangle, we have that all the sides are congruent. And because this is an all the sides are congruent, this means that it's equilateral. So we can assume that all angles are 60 degrees. This means this is 60, this is 60, and this angle is also 60. Now we know that this angle N is here, and what I don't know is the big angle. However, this arc right here means that this angle is 90. So I can assume that this angle here should be 90. So using angle addition, 60 plus n should equal 90. So if I subtract 60 from both sides, I would get n is equal to 30. Then from here, I can use the triangle to solve for my value of m. Because I have my angles are n of 30, my right angle, and this angle of m. So I could say 30 plus 90 plus m equals 180. So you'll have 120 plus m equals 180, and solve to get that m is equal to 60. So my answer is n equals 30 and m equals 60. In this next example, it says, what is the measure, if the measure of angle CBD equals 130, what is the measure of angle BAD? Now because this triangle has all these markings are congruent, we can assume it's equilateral, which means that all angles equal 60. So this is 60, this is 60, and this is 60. Now based on the given information, angle CBD is 130. So angle CBD is this angle right here, meaning that this whole thing is 130. So if I use angle addition, and if I call this angle A, I would know that my two little angles of the 60 and the A should add to my big angle of 130. So I'd have that 60 plus A should equal 130. So I get the A is equal to 70. Now the last thing is I have my big triangle here with these congruent markings. Since we have these congruent markings, we know it's an isosceles triangle. So we can say that the base angles are congruent. So if I call both of these angles x, I know that my angles of this triangle are 60, are x, and this angle is 70. So I could say that x plus 70 is 180. So 2x plus 70 is 180. Subtract the 70. So you get 2x is 110. And divide by 2 to get x is equal to 55. So I know this is 55 and this is 55. The last thing this problem is asking for is it wants to know what is the measure of angle BAD. If I look, angle BAD, I start at B, go over to A, and back to D. So angle BAD is talking about this angle right here, which we know has a measure of 55. So we say that angle BAD equals 55 degrees. In this next example, it says a triangle has angle measures of x plus 15, 3x minus 35, and 4x. Find the value of x. Now, if I start by drawing a picture, I'm going to label my angle. So I have x plus 15, 3x minus 35, and 4x. So I could say x plus 15 plus 3x minus 35 plus 4x should all add to 180. So when I combine like terms, I'll get 8x minus 20 is 180. And when I solve, I'll have 8x is equal to 200. So x is equal to 25. Now when I plug this back into the angle measures, I'll have that one angle of the x plus 15 gives me 25 plus 15, so that's equal to 40. The next angle of the 3x minus 35 gives me 3 times 25 minus 35 gives you a value of 40. And then lastly, if I have 4x, 4 times 25 gives me a value of 100. So this gives me my angle measures. So the value of x is equal 25. The angles are 40, 40, and 100. And then lastly, what type of triangle is it and why? Our answer to C would be that we see that these base angles are the same. So that tells us it's an isosceles triangle. So it's an isosceles triangle because base angles are congruent. For the next example, it says the length of the base of my isosceles triangle is x. So I'm going to draw my isosceles triangle with my congruent sides. And it says the length of the base is x. The length of a leg, which is one of the congruent sides, is 4x minus 2. So now this is 4x minus 2. Now, since the sides are congruent, I can also label this as 4x minus 2. Then it says the perimeter of the triangle is 113. So this means that the distance to go all the way around this triangle is 113. So I could use all of my side lengths and add them up to set them equal to 113. So 4x minus 2 plus 4x minus 2 plus x equals 113. So if I solve, I'll have 9x minus 4 is 113. So I'd add 4. So I get 9x equals 117. And then if I divide both sides by 9, this gives me x is equal to 13. In the last example, I also start by drawing a picture. So I have an isosceles triangle, and it tells us that the vertex angle is 4x. So these are my congruent sides. We know that our vertex angle is this angle here in between those congruent sides. So I'm going to label this angle as 4x. Then it says the measure of each base angle is 2x plus 10. So my base angles here are both going to be 2x plus 10. What is the measure of the vertex angle? The first thing we want to use is the fact that all the angles in a triangle equal 180. So I could take all my angle measures and set them equal to 180. So you'd have 4x plus 2x plus 10 plus 2x plus 10 equals 180. So if I simplify, I can combine like terms, so I get 8x plus 20 is 180. So I subtract 20 off 8x equals 160, and this gives me that x is equal to 20. Now if I want to find the vertex angle, is represented by this 4x. So my vertex angle will be 4 times 20, which gives you a value of 80 degrees.